8th grade math, test 26 study guide. Problem 1 says we have to decide which expressions are equivalent to this one given here. And so the first thing we want to do is simplify this expression. So I'm going to go within the parentheses first, and d is d to the first. So d times d squared, that's where we copy the base and add the exponents. So 1 plus 12 is 13. Now, the way we do exponent next to exponent, or power of power, the shortcut for that is to multiply the exponents. So I get d to the 26. So expression 1, we have d to the 10th times d times d to the 15th. So again, we're multiplying powers with the same base. So just like we did in the parentheses here, we just add those exponents, and I get d to the 26. That's the same as the given expression. The second, expression 2, is d to the 34th divided by d to the 8th. Well, the shortcut for dividing powers with the same base is to copy the base and subtract the exponents. So we have to go top minus bottom. Even if the top was bigger, we still do top minus bottom. And then we get 34 take away 8 is 26. So that's the same as a given expression. And expression 3, we had a mixture of both of those. And so expression 3 says d to the negative 3rd power times d to the 16th, all divided by or over d to the negative 13th. So what I want you to do there is do the top part first, okay? And then we'll do top and bottom. So remember that, do the top first. So what we do there again is to add the exponents. If we did teams, opposite teams mean subtract, so I do 16 take away 3 to get 13. And then I ask myself who has more. There's more positives than negatives. That's why it's positive 13 on the top. Now we're going to do just like we did in the last expression. Copy the base, subtract the exponents. Again, we go top minus the bottom, but the bottom's negative. This is where a lot of you get this wrong. You forget to write that second negative. Now, do your rule for subtraction, draw 2 sticks, do teams, and you can see you get d to the 26th power. That's also the same. So the last one is already simplified for us. D to the 26 is the same. So this time all 4 of them are the same. Looks like for number 2 we're going to have to solve this equation. So we want to do the rule for subtraction first. So wherever there's subtraction, we can do add the opposite. Draw 2 sticks. Then we're going to distribute. 1/3 times 9x is like saying 9x divided by 3. So 1/3 times 9x is 3x. 1/3 times negative 6, positive times negative is negative, and 6 divided by 3 is 2. Now we combine like terms. I combine my constants. Negative 9 and negative 2 are on the same team, so I add them. They're on the negative team. There's more negatives than positives, right? And then here, at this point, we want to get our x's together. It's not the only way to do it, it's just the easiest way to do it. Let's get our x's together first before we start moving our constants. So remember, step 2 was to get our x's on one side, so I subtract x from both sides, and I get this equation here. Now I'm on step 3. Remember, that's to isolate the variable, so we're going to work farthest away from the variable first, do inverse operations. Divide by the coefficient. And the solution for this, or the number that makes this whole thing true, is 14. Problem 3, it says which relations located under the graph have a greater rate of change. And the reason a lot of you are still getting this wrong is because you're still trying to find which of these down here is the same as this. But you have to be careful. You just have to read the directions to fix that mistake. This time they're asking us what has a greater rate of change. Or which one of these slopes has an absolute value that's greater than this absolute value. Okay? By absolute value, of course, I'm just pretending everything's positive, right? Okay, so, because even though something can be smaller number or a negative slope, it could be a greater rate of change than a positive slope if it's not as steep. So I look at the graph here, and I can take 2 points. And normally what we would do is we would just say, okay, I go down how much and over 1. Okay, but the trick here is if you go all the way down here, you see that's not 1, that's actually a half. So let's keep it simple. Let's go down this many and go over to the 1. So if I go down from 24 to 16, 24 to 16, I'm actually going down 8 units, correct? 24 take away 16 is 8. And then I go over 1. And that's a negative slope. So the slope for the graph is a negative 8. But I'm pretending it's positive 8, right? Because I'm just trying to decide what's steeper. All right, so I'm looking at absolute value. So relation 1, they tell us it's a proportional relation, which means that it goes to the origin. It also means I can take a shortcut in finding the slope. I don't need 2 points. I just need 1. So I put y over x and simplify. That's a slope of 4. A slope of 4 is not steeper than a slope of negative 8, because the absolute value of 4 is not greater than the absolute value of 8. So that's not steeper. It'll be shallower. Okay? So don't pick that one. Relation 2. They give us a table. And I don't see any 0 zeros in there, so I know it's not proportional. So there's no quick shortcut like relation 1. So I take any 2 points that I want. You might as well take 2 that has small numbers, maybe try to avoid negatives, but it doesn't matter. I ended up just taking these 2. You can pick 2 different ones and go off to the side and do that right now and make sure you get the same thing that I get in the video here. So we're going to go y minus y. And that order doesn't matter, right? Even though books tell us we should do y sub 2 minus y sub 1. The order doesn't matter. As long as if I go left minus right, I have to go left minus right on the bottom too. But this time, it's smarter to go right minus left, because that's going to avoid a negative. If I go 0 minus negative 12, that'll avoid a negative on top, right? Because minus a negative becomes addition. But if I do that on the for my y's, on the bottom for my x's, I have to start on the right also. So I go 1 minus negative 1. So I did right minus left over right minus left. My y's are on top. That's how we get our slope. I do the rule for subtraction. Draw 2 sticks here. 1, 2. And I get positive 20 on the bottom. 1, 2. Add the opposite, right? And 20 divided by 2 is 10. So relation 2 has a slope of 10, which is steeper than a slope of negative 10, because the absolute value of 10 is greater than the absolute value of negative 8. Relation 3, they already gave us the slope, because this thing is in slope. This equation is in slope-intercept form already. So just look at the number right there in front of the x. That number in front of x is a slope. Absolute value of negative 8.01 is more than negative 8. So that's going to be steeper or a greater rate of change. Now for relation 4, it's not in slope-intercept form. The y is not isolated yet, so we have to isolate the y. So remember, we work farthest away from the variable first, so I'm going to subtract 9x, take the whole thing. Take the 9 and the x with it. Because remember, we don't want anything on the same side as y, right? So now it says 3y equals this, so I'm going to divide everything by 3. Now, this is the part where you have to divide every single thing. When I add or subtract, I'm only combining like terms, so it looks like I'm only doing it one time. Over here, technically, I'm really just dividing this whole side by 3 once, even though it looks like I'm doing it twice, because this is all one expression. It's distributive property, but that's getting too complicated, so let's just memorize this. When we divide, we draw a line under everything. Alright, so we go ahead and see that when we finish simplifying this, you can cross out my 1's, right? And then negative 9 divided by 3 is negative 3. Negative 12 divided by 4 is negative 4. Now I can say what the slope is. The slope is whatever's in front of x right there. The slope is negative 3. That does not have an absolute value greater than the given graph. So the relations that are steeper or a greater rate of change is relations 2 and 3. Next problem, number 4. Looks like we're solving a system for number 4. And for number 4, they gave us one of our equations in the system that already has an isolated variable. So what I'm going to do is plug this into the other one where that letter is. So I'm intersecting these two algebraically to find out where they intersect graphically. In other words, I'm solving the system using the substitution method. So I plug this in where the y goes. So I'm going to write this one again, but instead of putting y, I put this stuff, because y is this stuff. Y equals this, in parentheses. Then I can do my rule for subtraction. I have a subtraction problem here, so I can do add the opposite. Over here, I don't need to do rule for subtraction, because even though that's negative, it's already addition. Right? I'm looking for what's in the middle of the two. That's addition, so I don't need to draw 2 sticks there. No rule for subtraction there. After I do my rule for subtraction, I'm going to distribute and combine like terms. That's how I simplify. Distribute, combine like terms. I distribute the negative 2. Negative 2 times negative 11 is positive 22x. Because there's an x there too. Negative 2 times 35 is negative 70. Now I combine like terms. Remember, when they're on the same side, I don't do inverse operations like I did over here, right? If it's a positive 9x, I subtract. I do opposite. That's because I'm moving something. Okay, I'm moving it. If it's already on the same side, you're not moving it. You don't do opposite. So if you see negative 22x, I'm not going to add 22x to positive 22x. I'm going to add negative 22x to 22x because I treat them the way they are when they're on the same side. I don't do inverse operations until step 2. Memorize that in class. Don't do inverse operations until you are done simplifying. So those two just cross out because those are opposite or additive inverses. So what's left over here, we have negative 70 equals negative 70. And I can't continue solving this because my variables canceled out. When my variables canceled out, either A, it's the same line, and my answer is, or my solution to the system is infinitely many solutions, meaning they intersect in infinitely many points because they are actually the same line, lined up. Or B, my other option is no solution. That means they're two parallel lines. That means they'll never intersect anywhere because they're parallel. And the way I decide that is if I have a true equation after my x's cross out, then that is infinitely many. If I had two different numbers, it would be no solution. If I ended up where it said x equals a number, well then I'd plug it back in and get y and get my one solution. I want to advise you guys, do not take that shortcut of just taking these answers here and plugging them in and seeing if they work and saying, oh, that's the one. Because now I am purposefully including numbers that will work for one and or both. And that doesn't mean that this is the answer or this is the answer. This time, infinitely many is the answer. So, long story short, don't take shortcuts. Learn how to solve it because you'll be tricking yourself, really, if you don't do that. You'll be missing problems that you don't have to miss. And next year, when you guys are in high school, your teacher may not give you multiple choice for this problem. You will need to do this again in Algebra 1, this exact same problem. And so you want to learn how to do it right now in 8th grade. So don't take shortcuts. Do it the way I'm showing you right here. All right, problem number 5. Problem number 5 says one equation is this, okay? And we have to decide if we made a system with these four, which one of those would make infinitely many, like the last problem we did. Now, we don't want to do all this work. We don't want to solve 4 systems. That's too much work. So there's actually a shortcut for this one. I don't mind you taking a shortcut for this one, because this one, they're already going to give you these for sure. Okay, this is a different problem where it's okay to take a shortcut. So one way you can tell if they are the same equation is if you multiply every one of these 3 terms by the exact same number, then they're the same line, then there's infinitely many. This is the quickest way to do this problem, okay? So if I look at A, for my given equation, there's an x, and for this one it's negative x. So how would I get from x to negative x? I'd have to multiply by negative 1. So what I have to check now is, do I multiply the other 2 by negative 1? If so, then that will make infinitely many solutions, these 2. So let's test. X times negative 1 is negative x, true. Negative y times negative 1 is positive y, true. Positive 15 times negative 1 is not positive 15, so A doesn't work. A will not make infinitely many solutions. Okay, let's take a look at B. So for B, be careful because I switched the order trying to trick you. Don't let me trick you. So if you start out with x, go to x first. So from this x to this x, I didn't change it at all. They're the same. So the rest of them should be the same also, even though the order is different. This one's negative y, that one's positive y, so B doesn't work. C, this is x over here, that's 4x. So I have to multiply x times 4 to get 4x. I have to multiply negative y times 4 to get negative 4y. And I have to multiply 15 times 4 to get 60. I multiplied by the same number every time. My answer is C. And D shouldn't work. Again, be careful, these 2 were switched, so go to your x's first. To get from x to negative 4x, that's times negative 4. To get from negative y to positive 4y, that's also times negative 4. To get from 15 to 16, that's times positive 4. That's not the same thing as negative 4. So the answer for that is C. Alright, so problem number 6. Okay, so problem number 6 says, Filthy John's Sand and Gravel Company will sell you decorative rock for your front yard for $87.75 per cubic yard with free delivery. Crazy Susan's Rock Liquidators will sell you the same rock for only $40.25 per cubic foot, but she will charge you $250 delivery fee to drop it off. So we have to pick the statement that is true, considering while you're considering which company you should choose. Okay, so let's go ahead and do this problem here. Now, the money that you pay if you go with Filthy John, it's going to be $80.75 every single cubic yard. Okay, so that's per cubic yard, or yards cubed. The other person, they're only going to charge $40.25 per cubic yard, but you're going to have to pay $250 for the delivery fee. So if you're trying to decide which one you should go with, think about what would make most sense. What would make more sense when you're deciding, should I go with these guys or these guys? Would it make more sense that I need to look at the slopes of each line? In other words, the rate, right? Because the rate of change is a slope. Yeah, it makes sense. That's cheaper, right? So maybe go with these guys, but we also have to consider this, don't we? So that's not enough. Next one, the Y-intercept of each line. Well, the Y-intercept means the starting point. Starting point means the delivery fee. These guys have none. These guys have 250. So now these guys look better. So that's not enough either. C, the number of cubic yards you need. Now, if I was only ordering 1 yard, I would go with these guys. If I was ordering 1,000 yards, these guys are going to be way cheaper. So that's what's matter. What matters is how much you're going to order. And 6, the name of each company. Oh, that's just silly. That's not the answer. Okay. Problem number 7. So problem 7 says this: write the equation for the linear function below. Now we have this table right here. In this table, my x, or my inputs, or my domain over here, or my first column, is not in order counting by ones. So we can't take that shortcut where we look at a table and we say, oh, I see the rate of change, I see the Y-intercept, I don't need to do any work. So these are actually not in order, so don't try to take that shortcut with this. Instead, take 2 points, any 2 points you want, get the slope by doing y minus y over x minus x, get your slope there. Then after you get your slope, take 1 point. Now, I taught you guys, if they give you a table, and if your x is 0, the other one has to be your y-intercept. I don't want you to confuse this point right here, 8, 0, with that. That is not the same as this, because here, even though it says w, that's my x column, right? My input, where x would normally go. That's not 0. So that, you can't look and say, oh, my y-intercept is 8. That's not true. If this said 0, 8, then you could say it is. But because it doesn't, you have to calculate the way we learned in class, which means find the slope, take 1 point and the slope, and use y equals m, or slope x plus b. I take my y here, my x here, I simplify, I solve this equation for b, and my b is -2. Once I got my slope, once I got my y-intercept, then I have my answer. Now, the thing is that normally we say y equals slope x minus 2, right? However, in this table, they didn't use x and y. So figure out which one's y. It goes x and then y, alphabetical order, right? So if this one is where my y normally goes, you have to use z. If you switch those 2 letters, that'll be wrong. So make sure you know which one's x and which one's y when you're choosing your answer. So for problem number 8, we have an equation here. It looks like we have to write the, we have a graph, but we have to write the equation. It looks like it hits down here at -1, so my b is -1. And to get from one point to the other, I rise 1 and run 3. So I got a slope of 1/3 and a y-intercept of -1. That one is that easy. Number 9, they give us 4 different triangles. We have to decide if they're right triangles. So if they are right triangles, then when we plug them into the Pythagorean theorem, it will be true, a true equation. So remember, the biggest one has to be the y-intercept. So you would say 3 squared plus 4 squared equals 5 squared. However, we memorized in class that the most famous right triangle is 3, 4, 5. If it says 3, 4, 5, it's obviously a 3, 4, 5. And multiples of 3, 4, 5 are also 3, 4, 5s. So that is obviously a right triangle. It's the most famous one. Next one, 12, 13, 6. We don't know if that's a right triangle, so I make sure that I use the biggest one as the hypotenuse, or the c. The other 2 don't matter. I go 6 squared plus 12 squared equals 13 squared. I simplify 6 times 6 squared is 36, 12 squared is 144, 13 times 13 is 169, and I see that when I add these two, that doesn't equal 169, so that won't make a right triangle. Next one. Again, make sure no matter what order it's in, use the longest one as the hypotenuse. So and call this a squared, this b squared. I can simplify here, and I can see 81 plus 144. I can stop because I'm not going to get 600 from numbers that small, so that will not make a right triangle. This time for triangle 4, they give us irrational numbers. So again, I can still look inside at the radicand, right, the number inside the square root, and say that one has to be the c. So I go a squared plus b squared equals c squared. We learned in class that a square root and a square cancel each other out. So I get 11 plus 15 equals 26. That is true. That is going to make a right triangle, so my answers are 1 and 4. All right. Now for number 10, they give us two lengths of a triangle, and they say it's a right triangle. And they say, what's the possible third length? Well, we have two options here. One, we can use those two as legs and do what we just did, Pythagorean theorem, only this time we're finding c. So we simplify. Notice that I don't subtract when they're on the same side. Remember, same side, just add them the way they are. Don't do inverse operations. This is a perfect square. So one option is the hypotenuse can be 14. Now the second option is this. Second option is this could be the hypotenuse and we're missing a leg. So if that's the case, we take the bigger one, put it over here for c. Again, simplify. Now this time I have to move this to isolate the variable. So when I move something, I do inverse operations. So this time I subtract 10 instead of adding 10 like I did over here. So I get b squared. I have to take the square root. Unfortunately, that's not a perfect square. That's an irrational number. But that just means I get to leave it. And there's my answer. Those are the two options for the third sides if we're making right triangles from those two lengths. Okay, number 11. At the exact moment, Superman flies over Metropolis train station. He sees Lex Luthor on the ground and zaps him with his heat vision. At that moment, Superman was 500 feet in the air, so he was 500 feet up here. And Lex was 900 feet from the station. So that's a right triangle. How long was the beam? In other words, find the hypotenuse for this right triangle. So we go a squared plus b squared equals c squared. Simplify, add, take the square root of both sides, and at this point we're using calculators, so we round that to the nearest tenths, and that's the answer right there. For 13, we're given this shape over here. I'm sorry, we're on 12. For 12, it says a right triangle has a hypotenuse of 12, so that goes here where the c goes. And the leg, that's 2.5. Find the missing leg. Again, Pythagorean theorem. This time we have decimals, though. We know 25 times 25. We memorize that as 625. But 1 decimal times 2 would give us 2 decimals, so hopefully you can even do that in your head. 12 squared is 144. Subtract. Remember, when you're subtracting decimals, you're going to line the decimals up, or if you got a calculator, just punch it in. And it says give an exact answer, so we won't type that in a calculator. We'll leave it like that since the radicand's not a perfect square. So it's that many units long. Okay, now for 13 we have a drawing like this, and we're going to take this whole drawing. We're going to reflect it or flip it over the x-axis. It's going to flip down here. Woo, that's a lot of drawing. Then it says we're going to translate or slide to the right and then slide one up. And then we got to find the coordinates for I. That's a tremendous amount of work. Or instead we can just look at I. I is at -5, +3. So what we're going to do then is take -5, +3, and we'll do those transformations just with that point, because that's all they're asking us about. No need to try to draw that whole thing. Probably going to get it wrong that way anyways. So with -5, +3, if I'm going to reflect that over the x-axis, that means change the sign for y. So now I prime, or the first transformation, is there. Then 4 to the right and 1 up. 4 to the right means add 4 to -5. You can use teams if you need to. I get -1. And 1 up means add 1 to the y. So the x's go right and left. The y's go up and down. That's your answer. Alright, 14 says segment LM begins at where L is at 3,5 and M is at -3, +5. And then it says the segment, that shape is translated or slid x, y plus 4. That means it went up 4. And then rotated 180 degrees clockwise. And that's around the origin, of course, to form L prime, M prime. And technically we should have said L double prime, M double prime, right? And then they ask us how long it is. Well, the truth is, as long as we do not dilate, then the size doesn't change. So we don't even need to worry about all those transformations. As long as they don't say dilation, the size doesn't change. And even if they did say dilation, I would find the size and multiply it by the scale factor. We'll talk about that at another time. So all I have to do is find how long is LM. L is at 3, 5. M is at -3, -5. So I plug in, I go x minus x squared plus y minus y squared. Or in other words, this is Pythagorean theorem, right? A squared plus b squared equals c squared. So I take the square root of the whole thing. That's what we do to find, at the end when it's c squared. Okay, so here's the distance formula. Plug your numbers in. And there's our points right there. So I went x minus x, so I put my x's over here. Sorry about that. And y minus y, I put my y's there. These can be switched. It doesn't matter because it's addition. So then I simplify. If I take away 5 is 0 squared. Draw 2 sticks. 0 plus 36 is, square root is 6, so it is 6 units long. Okay. 15, we have to take the volume of a cylinder. Volume of a cylinder is pi r squared h. We memorized that in class. Pi is always 3.14. And they tell us that the diameter is 6.24, so we cut that in half. We divide it by 2. And they give us the height. Now, in our calculator, just make sure you type this first. 3.12 times 3.12. Do that first. Then times 3.14, then times 11, and you got it. 16. So the question is, we have a shape right here, and they're saying, does the big cylinder, is it 3 times greater than the small one? Now, we learned in class that if the height is 3 times greater, then yes, it is. But we also learned in class that if the radius, but for that to happen, the radius has to be the same. So the radius changed. So we already know that this won't be 3 times bigger. Well, I hope you do. So we look at the height. If it's 3 times bigger, yes. But if the radius is not, then no. If the radius was just 3 times bigger, that wouldn't work either. It's just the height. So when we solve this, we got to say why. Okay. So we already know it's not going to be 3 times bigger. So my answer is going to be C or D. But which one of those C or D is the reason why? So if I find the volume for the big one, that's just pi r squared h. The bottom one, again, pi r squared h. We do that in our calculators. And so here's the thing. If I look at this, and I can see that the smaller one times 3 doesn't equal the bigger one. So I know it's not 3 times bigger. Or the bigger one divided by 3 doesn't equal the smaller one, right? So now if I look at my answer choices for C, it says C. No, it's not 3 times bigger because I'm just checking to see did they plug it in the same way I did. Over here, did they plug it in the same way I did? Okay, and then the times 3 part. Or, for D, did they do something wrong? So for D, you can see what they did for D is they used the height as the radius instead of the radius as the radius. That's why D doesn't work. You see, they put the height where the R goes. So that's why you wouldn't pick D for that answer. So for 17, we have a cylinder. And they're trying to trick you by putting the radius down here, but it's the same thing. Just put it up top. So all we're doing again is pi r squared h. Make sure you do this part on your calculator first. And the answer is in cubed units. You guys pause the video and try that. Make sure you get what I got. And 18, we're finding the volume of a cone. So we learned that cone is the same as cylinder, but then divided by 3. So plug your numbers in, grab your calculators. Again, do the radius times radius first. Then times this, then when it's all said and done, just hit divided by 3. So same as this problem, but when it's over, we hit divided by 3, and we get the answer for that one. So for 19, they give us 2 containers. They want us to find the volume for both. The first one is a sphere with a radius of 20. Okay, so I put 20 where the radius goes. I always use 4/3. But now in my calculator, what I do to get the answer is, again, do your exponents first before you do multiplication or division, right? So I go radius times radius times radius. So 20 times 20 times 20. Then times 3.14. Then times 4. After that, divide by 3. And that's the order to get the right answer. So the hemisphere is half of a sphere. So what we're going to do is do the same thing again. So we plug in the numbers. Okay. We go radius times radius times radius times 3.14 times 4, then divided by 3. But now, since it's only half, after you hit divided by 3, you got to do divided by 2 again. There's a trick right there. You got to divide by 2 again. All right? So, and that's how you guys are going to get that answer. And for 20, we have a sphere and a cone that have the same volume. So that means this. A sphere, here's the volume for a sphere. A cone, here's the volume for the cone. If they have the same volume, they're equal to each other. Alright, so it says the height of the cone, it says find the height of the cone. Okay? It says they each have a radius of 4 inches. So I'm going to plug in the numbers that I have. I always have 4/3. I always have 3.14, but you know what? I'm just going to leave it as pi for now. Treat it kind of like a variable. They give me the radius for each. I plug in a 4 for where the r's are, and I don't have h, so that's what I'm solving. I'm going to simplify both sides. 4 cubed is 64. 4 squared is 16. Okay? Now, if you wanted to do all this work in your calculator, you could, but it's going to get messy. Instead, you see how they're both over 3? If you multiply 3 by both sides, watch what happens. Those 3's cross out. So now we have this. Look, there's a pi on both sides. So what do? I divide both sides by the pi. That crosses out. And then I'll divide by the 16. And h is going to be 256 divided by 16. Pause the video and make sure you guys can do this on your own. And there's our answer. Hope that helped.